Now we're going to talk about the mean squared within, and it's the average variance within the groups. And it's kind of how much we expect the means to vary just by chance. And this is analogous to the standard error for a t-test. So when we did a t-test, we did standard error. But this is kind of not a squared version, right? This is in kind of like standard deviation metrics. And because the mean squared between is in a variance metric, we kind of have to do the same for the bottom to make it comparable. And so we have the mean squared within, which is kind of an average variance within the group. So in these two examples, we have the mean squared between is equal. The distance you can see between the groups is, between the sample means, is all equal. So, you know, the dotted lines are in the same place. So the mean squared between betweens are equal to each other. And just for these two examples. But what I want you to look at is the variance within each group. So in the first one, we have a low mean squared within. And you can see the distributions are kind of compact. The widths are little. So the distance between here and here, and then here and here, and here and here is smaller for this first one than on the second one. See, we have a longer distance between here, so the variance for each group is going to be smaller in the first one than in the second one. And so when we kind of average it all out, you know, the average variance within each group is going to be smaller for the top example than the bottom example. And when that happens, it's more likely for the top one to be significant than the bottom one. And hopefully you can kind of see that there's less overlap for the distributions in the first one than in the second one. So if you just kind of look at this intuitively, hopefully you can kind of see that in the first group that the difference between the sample means looks kind of bigger than in the second one because there's less overlap of the distributions. And so you're more confident that there's actual difference when there's less scores being overlapping with each other than the second one where the sample means are in the same spot, but we have more overlap of the distribution of the individual scores, and so you're just not as confident that there will be a difference. Okay, so this is kind of, the mean squared within is kind of a version of standard error, but for ANOVA, and when we have 3 or more groups. So calculating the mean squared within is basically you find the sum of squares for each group, and in this example they're just given to us. Sum of square for the first group is 5, the sum of squares for the second group is 6, the sum of squares for the third group is 4, and then we have our ends again, which were all 20. So we're going to find the total within variance. And so all you got to do, super simple, when you have the sum of squares. So you're just going to, so you have the MS within is just going to be the first sum of squares plus the second, and then plus the third. And then we're going to divide it by the degrees of freedom. And so our total N as you can see, we add 20 plus 20 plus 20 is 60. So we're going to put 60. And then because for the sum of squares I don't know if you kind of remember this, but when we do degrees of freedom, the amount that you subtract off is based on how many sample means that you had to calculate, you had to estimate. And so for each sum of squares, we had to find an average for each group. So to get these sum of squares here, we had to do 3 x bars. We had to find 3 sample means. So that means we're going to have to subtract off 3. And that's just because we had to estimate these sample means, so we have a little less kind of information to base our variance on. And remember, I don't know if you remember this, but sample variance tends to be underestimated, so we have to kind of subtract off for each sample mean that we have to kind of make this overall variance a little bit smaller. So we're going to have 5 plus 6 plus 4. So that's going to be 15. And then we're going to divide by 57. So 15 divided by 57 is 0.26. That's it. So it's the sum of squares, you just add those up on the top here. Then do the total n minus the number of groups that you have.